Hello, everyone. We are Group 17. We are doing stock price trend prediction and relations between stocks. We are wondering, do stock prices rise and fall together? And we will look at this problem from a purely numerical perspective. First, we use clustering algorithms such as nearest neighbors to form clusters of related stocks. And then we use this group of stocks to do vector autoregression, which is a time series model to predict the future trend. And we initially got our data from kaggle.com. It is a 10 gigabytes data, which contains all the historical price information of over 2,800 companies. And after we got the data, we also use Yahoo Finance and Airflow to update it daily, which gives us 15 megabytes more data per day. Then we process our data to data points with 1,000 consecutive days of close prices, excluding the stocks with too little data. And then we use ANOI, which is a fast implementation of approximate nearest neighbors in Python to form our clusters. So ANOI basically, it just cuts the data points randomly into small shards and build a binary tree with the small shards. Then it just search the shards that contains the target value. Then it will rank all the points in the target shard and the neighbor shards to get the most related points. After we build our ANOI, we did some evaluation. ANOI always give us stable number of stocks in a group. And also the building time is 0.1 seconds with almost instantaneous query time.
After that, we built a vector autoregression, or VAR model on the group of stocks produced by ANOI. VAR models are used to model the relations between multiple time series, such as stock prices. They consist of a system of equations, one for each stock. And for example, a simple VAR model of two time series, Y1 and Y2, would have two equations. The first equation would model Y1 at time t as a function of Y1 at time t minus 1, meaning the day before, and Y2 at t minus 1, which is the day before. And the second equation would model Y2 at time t as a function of Y2 the day before and Y1 the day before. So why did we choose to use a vector autoregression model? There are many advantages of VAR models. First of all, every variable is treated as dependent. So the model does not assume that any variables are independent, and it fully captures the dynamic relationships between variables. This is good for modeling stock prices because the prices of related companies tend to be correlated. And when the price of company A changes, that might lead to a change in the price of company B, which could lead to another change in the price of company A. And this type of dependency relationship is captured very well by VAR models, but not very well by other regression models, such as linear regression. In addition, VAR models are easy to estimate because you can just estimate them using ordinary least squares for each equation. And they have good forecasting capabilities because they can predict prices for many days into the future instead of only the next day. There have been many previous works that have shown that VAR models are useful for predicting stock prices. For example, there was a study in 2018 that used a VAR model of 20 highly traded stocks, and they found that the prices of those stocks were very highly predictable using VAR models. However, previous works had some important limitations because they usually only considered a small number of stocks, and their data and models were not continuously updated. In our project, we include over 2,000 stocks, and we update our stock price data daily. In addition, we always fit our VAR models on the most recent stock price data. The way that we implemented our VAR model is that for a given stock, we first find the 10 most related stocks using ANOI. Then we fit a VAR model on those stocks using data on the daily percentage change in prices. Then we compute impulse response functions for each pair of stocks in the group, and those show the predicted effects of change in one stock's price on another stock's price in the next few days. And here is an example graph of an impulse response function for two stocks. After building our VAR models, we did some experiments by using a moving window of training days to predict the next few days with a group of stocks. And we changed the number of training days and the number of prediction days and the number of stocks per group. Then we compared our predictions with the actual prices on those days. And we optimized our model by performing grid search and found that the optimal combination was to use 900 training days, 5 prediction days, and 10 stocks per group. And we tested this model on a group of 50 random companies and 20 random days. And this resulted in an average error of 0.84%. And our predictions were unbiased, which means that we do not consistently over or underestimate stock prices.
Okay, so that's our final design of our system. We use Airflow to update our data. And after process the data, we use Python to do the ANOI to get the similarity of the data sets, the stock prices. And we use Python to use the VR model to get the impulse response functions. And based on the results, we use Django to build an app. So now I will use a demo to show how to use our app. Okay, so here is our page of our app. Now you can see that on the top, there's an introduction. You can enter a company of your interest below, and we will use the ANOI to find 10 companies most related to the one you entered, and then we will recommend operations on your target stock with a VR model. Here you can click on these two links to know more about the ANOI and the VR. So now you can enter the company code such as AAPL, which means Apple company, and you can choose this as impulse or response. Here we choose impulse. Below that, we show the functions of our app. You can see that the table below displays the results. The similarity column shows how strongly related the companies is to your target company. For example, 5 means they are the most similar one, and 1 means it's the least similar one. And if you select impulse, the prediction columns will show the predicted percentage change in the price of each company in the next 5 days. If the price of the searched company will increase by 10% today. If you choose response, then the prediction columns will show the predicted percentage change in the price of each of the searched company in the next 5 days. If the price of the corresponding company will increase by 10% today. And will also show the recommendation, and it will be the buy or sell or neutral. It will show buy if the price of the corresponding stock will be greater than the current price in the at least 4 of the next 5 days. Sell means that it is less than in the at least 4 out of the next 5 days. And now if you click on go, you can see that the results is printed on our page, and you can see the similarity of the 10 companies. These 10 companies is the most related companies to AAPL, and you can see the next 5 days predict stock price change. And now you can see that all of these stock price predictions are minus, or most of them are minus, and some of them are positive. And the recommendation we give to all of these companies are sell. So it means that we recommend you to sell these 5 companies stocks. And below that is a line chart which shows the stock price changes of these 10 companies. And you can see that there are 10 lines in the chart, and you can click on the legends to choose which 7 lines to be shown on the line chart. And now you can enter another company code, for example, FB, which means the Facebook, and you can choose it as impulse or response. Now you can choose response. Now click on go, then you can see the new results. So that's the new result when you enter the Facebook and you choose it as response. Now you can see the result of the similarity, the next 5 days predictions, and the recommendations we give to you. And here is also a line chart, and you can also click on the legends to choose which 7 lines to be shown on this chart. Okay, to make a conclusion, we have successfully achieved our goal. Since our topic of our project is stock price trend prediction and relations between stocks. Now we get a similarity to show the relations between stocks, and we can predict the next 5 days stock price change. We also provide recommendations and line charts in our app, which are very helpful for the users to make decisions. However, there are still many deficiencies that can be optimized, and we can improve our project. First, now we can just predict the next few days stock price changes as the result of the stock price change prediction converges to 0. So if we want to predict the stock price in a very long time, for example, in 1 month, we need to use some other methods to achieve this goal. And we can also improve our project to decrease the prediction error. And as the vacancies might exist in the actual data, we can complete the data set to ensure the data integrity by ourselves. So in future, we may use more models and methods to improve our project. Okay, so that's the end of our project, and thank you for listening.